This video will show the behavior of the tangent lines of a given function. This will help us how to graph a function using their derivatives eventually. Recall that when we refer to the first derivative of a function, it refers to the slope of the tangent lines of the function. So consider this as the change in y over the change in x. Suppose we have the points 2, 1 and 5, 4. This is point 2, 1 and this is 5, 4. And when we compute for the slope of that line, we have y sub 2, which is 4, minus y sub 1, which is 1, over x sub 2, which is 5, minus x sub 1, which is 2. So that will give us 3 over 3, which is 1. And suppose we have 2, 1 and 0, 4. This represents these 2 points that when we connect, it will form this line. When we compute for the slope, we have 4 minus 1 over 0 minus 2. And that is 3 over negative 2. So notice that when the line is leaning to the right, the slope is positive. And when the line is leaning to the left, we have a negative slope. Now, given the graph of the function, let's observe the tangent lines, which is represented by the yellow lines here. Here we have the tangent line of that function touching the curve, let's say at this point. As the point moves to the right, did you observe something? If not, let's try to give the slopes some values. So here we see that the slope of the line is 8. Note that the slope of the tangent line, which is the yellow line, is leaning to the right. That's why the slope is positive. Now observe the value of the slope. Here we have 8, 5, 3, 1, 0.7, 0.3, 0.1, 0. Negative 2, negative 4, negative 8, negative 4, negative 3, negative 2, negative 1, negative 0.8, negative 0.5, negative 0.3, negative 0.1, and 0. 0.3, 0.6, 0.9, 1.2, 2, and 4. Let's take a look at the graph faster. Did you notice anything? One more time. Now, did you notice anything? If not, let's give colors to the slopes. Observe the value of m here. It's written in maroon. Let's observe that color. It changes to red. Then it became purple. It became red again. And it became maroon again. Did you notice anything? This time, let's move the tangent line faster. One more time. Did you notice anything? What you must notice here is that the letter M is written in maroon every time that the slope is positive. It becomes red when the slope becomes 0, and it becomes purple when it becomes negative. Let's observe that again. So the letter M is written in maroon. It is red because it's 0. It's red because it's 0 again. and it's maroon because it is positive. Let's take a look again. It's maroon because it's positive. It's red because it's 0. And it's maroon because it's positive. Now let's try to add more colors. This time at the value of the slope. Observe here that this is written in dark blue. It changes to yellow, then it changes to green. Did you notice something? One more time. It's written in dark blue. It turned yellow, and then green. Now, what you must observe is that the value of the slope is written in dark blue when the tangent line is rotating clockwise. It becomes yellow when the tangent line stops rotating, and it becomes green when the tangent line is rotating counterclockwise. Let's take a look. It's written in dark blue because it's rotating clockwise. It becomes yellow once its rotation changes. Now it will move counterclockwise. Did you notice that? The tangent line here is moving clockwise. It stopped, then it's moving counterclockwise. It's moving clockwise. It stopped, then it moved counterclockwise. Now let's summarize. What you must have noticed is that at this part of the graph, from negative infinity up to this point, the slopes are all positive. Then as it moves from this point up to this point, all the slopes are negative. Then as it moves from this point to that point, all the slopes are again positive. This shows that whenever that the slopes are positive, the line is increasing. It goes up from left to right. And if the slopes are all negative, at that interval, the curve or the graph is moving downwards. And then once the slopes again are positive, the graph is increasing. So this shows that if the slope is positive, it represents an increasing function. If the slopes are negative, it represents that the graph is decreasing. Now, at this point, the slope of the tangent line is 0. Likewise, at this point, the slope of the tangent line is also 0. This shows that whenever the slope of the tangent line is 0, that point is either the maximum or the minimum of the curve. So this shows that this point is the maximum point and this point is the minimum point. Now, the maximum and minimum points of the curve is either what we call the relative or the absolute maximum or minimum. When you have this curve, this point is a maximum point. This curve is also a maximum point. However, this one is what we call the absolute maximum, while this one is called the relative minimum. The difference is that when we say absolute maximum, it's the highest point of any part of the curve. While when we say relative maximum, it's the highest point of the curve only at some interval. Meaning, there may be other points that is higher on that point of the entire curve. Now, how about this point? This point is a minimum point. And since there are still points that's lower than that, that will be called as the relative minimum. If this is your curve, this point is a minimum point and this point is a maximum point. However, there are still points that's lower than the minimum point, so this minimum point is what we call the relative minimum. Likewise, this is a maximum point of the curve. However, there are still points that's higher than that. So this is a relative maximum. Consider this graph. This point is a minimum point. However, there are still points lower than that. So this is relative minimum. This point is a maximum point. However, there is still part of the graph that is higher than that. So that is relative maximum. This point is a minimum point. However, there are no points lower than that on the entire graph. So this is an absolute minimum. This point is a maximum point. However, there are still parts of the graph that's higher than that. So this is relative maximum. And this point is likewise a relative minimum. So now you know the maximum and the minimum points. Again, these are the parts of the graph where the slope of the tangent line is 0. Now, a while ago, you saw that the tangent lines are moving clockwise, and then, upon reaching a certain point, the direction of the tangent line tends to change from clockwise to counterclockwise. That point where the tangent line changes direction is what we call the inflection point. In this case, this is the point of the graph where the tangent line changes its direction clockwise to counterclockwise. And this is called as the inflection point. So on the examples of the next videos, where we're going to identify the maximum and the minimum points as well as the inflection points. We will just determine first the value of x, let's say x sub 1, where that point has a tangent line which is 0. And that point may either be a maximum or minimum. We were also going to identify the inflection point. If you have, for example, f of x as x cubed plus 5x squared minus x plus 1, the degree of this function is 3. That 3 refers to the number of directions of the graph of that function. Meaning, since this is x cubed, or the degree is 3, the graph of this function will have 3 directions. Let's say 1, 2, 3. If that is negative, the tendency is the graph will have still 3 directions, but it will start from top to bottom. 1, 2, 3. So somehow this gives you an idea of how the graph of that function will look like. If you have x raised to 4 plus something, since this is 4, it will have 4 directions. 1, 2, 3, 4. Now if that's negative, the graph will just flip. So that will be 1, 2, 3, 4. How about if you have x raised to 5 plus something? So rest assured that that will be 1, 2, 3, 4, 5. So that gives you a clue of how the graph of the function will look like. Now you may click the next video for the examples.